In question 10, we have a particle that is traveling on a straight line. So we'll say like this is the line that it is traveling on, and it's starting at some initial point, which I'll mark it with this. So the equation is going to be S of t. S is measured in meters and t is measured in seconds. What we're going to do is find a formula for the acceleration of this particle, figure out where the acceleration is 0, and also determine when is the particle speeding up and when is it slowing down. All right, let's take a look at this one in part A. S of t is equal to t to the fourth minus 32t cubed. I graphed this thing in Desmos, and I had to really zoom out to get a good picture of it, but here it is. If we have a negative value for the position, that just means we'll say the particle is like moving to the left, so that's if you have a negative position. But if it's positive, we'll say that it's moving to the right. That'll be our convention. First, I want to find a formula for the acceleration. To do that, I first need a formula for the velocity, which is the derivative of this function, and that is going to be 4t cubed, and then we're going to subtract off 3 times 32, so this is going to be 96t squared. So this formula will tell you how fast this particle is traveling at any given unit of time, where t is going to be greater than or equal to 0. A negative velocity means we're going to the left, and positive means we're going to the right. Okay, but that still is not the acceleration. The acceleration is going to be the second derivative of this equation. That is the derivative of the first derivative, and this is what we're going to call a of t. To figure that out, I'm just going to take the derivative of this equation, and we get 12t squared minus, 2 times 96 is 192t. So here it is. The first question is, when is the acceleration 0? I have a formula for my acceleration. If I want to figure out where it is 0, I'll take my formula, a of t, and set it equal to 0. Essentially what we're doing is solving where is 12t squared minus 192t equal to 0. I think to figure this out, I'm going to factor it. I see I can take out a 12 and a t from both terms, and what is left over is, we get t minus, and I think that's 16. So in terms of where the acceleration is 0, that's where each factor is equal to 0. And t equals 0 and t is equal to 16 are the two places where that happens. That is here. And I'm going to try to mark it as best I can, but like on the graph, that is right here. Okay. Now, in terms of where this thing is speeding up or slowing down, we're going to have to use not only the acceleration formula for that, but the velocity formula too. What we're going to have is, if both your acceleration and your velocity are positive, or if the acceleration and the velocity are both negative, this means that the acceleration and the velocity are working together. If they're both positive, that means we're moving in this direction and it's speeding up. If they're both working together in the negative direction, it means it's speeding up but going this way. So this here that I have marked down is speeding up. So this is going to mean that slowing down is if the following happens. So slowing down means that your acceleration, let's say, is positive and your velocity is negative, or the acceleration is negative and the velocity is positive. If they're opposite in sign, that means they're working against each other. So to figure out this part of the question, what I'm going to do is graph both the velocity and the acceleration together and just try to indicate where these things are happening. And I'll do that on the next slide. So here I have a graph of the velocity and the acceleration. I'm going to solve these equal to 0 and figure out where they are positive and where they are negative. So starting with the velocity, that is 4t cubed minus 96t squared. Where's this equal to 0? Again, I think I'm going to take a factoring approach. I think this will work out pretty well. If I factor out a 4t squared, what is left over is t minus 24. This is 0 in two places, t and 24. So, okay, this must be 24, and the other spot here is 0. So in terms of the velocity, okay, the velocity is negative here, but it is positive here. Now what about the acceleration? The acceleration is 12t squared minus 192t. I'm saying that equal to 0. Again, I think everything is divisible by 12. Let's see. Yeah, if I take out a 12t, right, we did this last time. It was t minus 16 that is left over. So we also have t is equal to 0, but also t is equal to 16. It is 0 in two places as well. That's here and here. So this is where the acceleration is negative, but then it flips over and then the acceleration is positive. So there's really three intervals to consider, from 0 to 16, from 16 to 24, and then greater than 24. So let's write all of those down. From, let's see, 0 up to 16, but not including it, we have that both the velocity is negative and the acceleration is negative. This means speeding up. And of course, that negative is just indicating that we're moving to the left instead of the right. Then from 16 to 24, okay, we have that the velocity is negative, but the acceleration is positive. That's a mix of signs. Those two things are working against each other. This is slowing down. And then lastly, if we are greater than 24, from 24 and on, both the velocity and the acceleration are positive, and that means speeding up. And that's it. For part B, again, we have a s of t function, which is telling me the position of a particle. Now, this plus 1 means there's an initial point, but it's actually starting 1 meter away from it. And then it's like moving to the left, and then eventually gets back to that point and starts moving to the right. So this plus 1 is still meaningful. It's just saying you're starting away from that initial point. Okay, so step 1 is, if I want the acceleration, and I also want to figure out where it's 0, I need the velocity function, which is the derivative of your position. And using our derivative rules, we get 12t squared minus 48t. All right, but if I want the acceleration, that's the second derivative, or it's the derivative of your velocity, we're calling it a of t. That's going to be equal to 24t minus 48. Great. The place where the acceleration is equal to 0 is whenever 24t minus 48 is equal to 0. No real point in factoring. I'm just going to add 48 to the other side of the equation. I'm then going to divide both sides by 24, and I get my value of 2. Now, can I actually see this on the equation itself? Well, here's t is equal to 2, and so we are referring to this point on the graph, so I'm going to mark it. That is right here. There is a name for a point like this on the graph. We'll define this more carefully later, but your original function can have something called concavity. That means, is your graph opening upward, or is it kind of like curving downward? So this part of the graph is opening up, and we call this concave up. This is starting to curve like back, curving down, so this part of the graph is concave down. And there's a point where this change occurs between concave down to concave up. And we call this an inflection point. And it turns out if you have an inflection point on your graph, it must be that the second derivative at that point is equal to 0. This doesn't work backwards. If your second derivative is 0, it doesn't mean you have an inflection point. But if you do have a point like this on your graph, the second derivative, which is the acceleration, must be equal to 0 there. Now, to completely answer this question, what we want to do is figure out, well, where is this particle speeding up and where is it slowing down? What I'll do is graph both the acceleration and the velocity together. I'll figure out where they're positive and negative, and I'll answer it from there. All right, so here's our velocity function and our acceleration function, velocity in blue, acceleration in green. We already figured out where the acceleration was 0, and that's right here at 2, so everywhere else is either negative or positive. We still have to deal with the velocity, so like, okay, where is the velocity equal to 0? That's wherever 12t squared minus 48t is equal to 0. I can factor out a 12t, and what is left over is t minus 4. You probably can also see this from the graph, but the two solutions are 0 and also 4. So if we focus on the velocity, it's 0 here and here, and between this spot and this spot, the velocity is negative. But then over here, your velocity is positive. In terms of the acceleration, okay, from here to here, your acceleration is negative. But then from here over here, your acceleration is positive. This gives us 3 regions to consider: 0 to 2, 2 to 4, and then beyond 4. So if we examine these, between 0 and 2 seconds, both the velocity and the acceleration are negative. That is speeding up. Between 2 and 4 seconds, the velocity is negative, but the acceleration is positive. That is slowing down. And then if we are beyond 4 seconds, both the velocity and the acceleration are positive, and that means speeding up.